This is Unit C, or Unit on Calculus, and this is called the Introduction to what is called Differential Calculus. And we're going to start off with Section C.1, finding the equations of secant lines. Now I want you to write the following. What do you need to determine the equation of a line? Start with, what do you need? You need the slope. We often call it m. And we need a point on the line. It doesn't have to be the y-intercept or any particular point. It's just a point whose coordinates we can call x and y. Now, if you have a point in the slope, fill this in. What formula would you use? If I have to figure out the equation of a line and I have a point and I have the slope, the formula that I would use is called the point-slope formula. Not the slope-intercept formula. I don't have necessarily the intercept. I might, but not necessarily. Here's your point-slope formula. Y minus y sub 1 equals the slope m times the quantity x minus x sub 1. Now let's go to the next page. Example number 1. Given a line that passes through -2, 3, and 1, 1, write this. Find the equation of the line in slope-intercept form. Well, slope-intercept form is different than point-slope form. Slope-intercept form is y is equal to mx plus b. So our answer has to be in the form y equals mx plus b. So we have a coordinate plane. So what we're going to do is draw the line that passes through those 2 points. We're going to start by plotting those 2 points in red. Let's make the points stand out. So we're going to plot a point at -2 and 3. And we're going to plot a point at 1, 1. Then we're going to grab blue and draw a line through those 2 points. Like so. So that's our line. Now we need to come up with the equation of the line in slope-intercept form. Now we could do that pretty quickly using our algebra skills, but we're not going to do it pretty quickly because we're going to develop some calculus notation as we talk about this algebra. First of all, to come up with the equation of a line, we need the slope of the line. And we know, write this, that slope is equal to rise over run. And so we could figure out the slope by saying from this point, whose coordinates are 1, 1, we could rise, so put a little ray, rising 2. So we'll put plus 2. And then we could go left. That's our run, so that would be -3. So we could figure out the slope by saying the rise is +2 and the run is -3. So that means the slope is -2/3. Or we could have gone from this point right here and gone down 2. So that's a -2 is our rise. And then we could have gone this direction and said +3 is our run. And we could write rise is -2 and run is +3. And either way, the slope is -2/3. You also learn about slope that there's a formula for slope. Slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then the 2 points that we were given, we could say the first one is x sub 1 and y sub 1, and the second one is x sub 2 and y sub 2. it doesn't really matter whether we call the first one x sub 1 and y sub 1, or the second one x sub 1 and y sub 1. But however we do it, we need to then substitute in here. We could say that we have y sub 2 is 1, and we subtract y sub 1 is 3, and that's over x sub 2, which is 1, minus x sub 1, which is negative 2. So that would give us a negative 2 over 3. And so basically that's negative 2/3. Now, write slope again. Slope can be described in words. We have rise over run in words, and we have a formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But we could write the words like this. Slope is a change in y values over a change in x values. Change in y values over a change in x values. Now, we're going to learn calculus notation. Slope is equal to change in y values can be written as this triangle y over this triangle x, but this is read delta y over delta x. It's just like on our calculators when we go to set up a table. We have delta table. That delta there means change. Okay, change in our variable. Here, delta y means change. Change in the y values over change in the x values. Or this can be written delta y over delta x. In calculus a lot, you'll see dy over dx. dy over dx. All right, now, it said find the equation of the line in slope-intercept form. We're going to start with the point slope formula. I want you to write this in green. Y minus y sub 1 equals m times the quantity x minus x sub 1. And then we're going to substitute in one of the points, and we're going to substitute in the point which we designated as x sub 1, y sub 1. And we're also going to substitute in the slope. So we're going to have the following. We're going to substitute in for the slope negative 2/3, and for x sub 1 negative 2, and for y sub 1 3. But the directions specifically said that we need to write the answer in slope-intercept form. So we need to get y by itself and put it in slope-intercept form. So we'll do our algebra. First, x minus a negative 2 is x plus 2. Then I'm going to distribute the negative 2/3 on the right side of the equation, and I get y minus 3 equals negative 2/3 x minus 4/3. Now I want to get y by itself, so I'm going to add 3 to each side. So now we're going to change 3 so that it is 9/3, so it has a common denominator. So that's going to give us then our answer. Y equals negative 2/3 x plus 5/3. And then underneath that in green, I want you to write y equals mx plus b. That's your slope-intercept formula. Get those clear. One is your slope-intercept formula, and the one we started with was the point slope formula. Now let's move on to the next page. Write this. What is a tangent line? Here's an example. Draw a circle And then that's a tangent line. It's a line that touches that circle in one and only one place. Next, what is a secant line? A secant line intersects a circle in two places. Only two places. Now, what are the following called? Draw this diagram. When I say the following, I'm referring to what's in blue, not the black graph, but what's in blue in relation to the black graph. Neither one of these blue things are lines, they're both segments. The first one is tangent segment. The second one is a secant segment. So sometimes we'll be talking about tangent lines, sometimes tangent segments, sometimes secant lines, sometimes secant segments. Now let's go to our last page. Example number 2. Given f of x, we have a polynomial function, x cubed minus x squared plus 2x minus 3. First, it says write this, find the slope of the secant that connects x equals -1 and x equals 3. So write that out. Now using our calculator, we're going to go to y equals and we're going to graph this. So we're going to have x cubed minus x squared plus 2x minus 3. Let's graph it in Zoom 6 to start off with. Okay? Well, we want to find the slope of the secant that connects x equals -1 and x equals 3. If we press trace, you can see the cursor blinking at x is 0, y is -3. That's the y-intercept. If we press -1, enter, that means when x is -1, y is -7. So those would be the coordinates of that point. If we press 3, enter, when x is 3, y is 21, which is off of our coordinate plane because our coordinate plane goes up to y is 10. If we change the window, the viewing window, so that we can see this point, press window, arrow down to y min. Let's make y min, leave it at -10. Let's make y max be 25 and y scale be 2. Now graph it. Now if we press trace and we press 3 and enter, we can see that point. Okay? All right, what I have here is the equation we entered on the calculator, what we saw when we first graphed it in Zoom Standard and then did trace and we did x is equal to -1, we saw that point. Then we changed the viewing window, we changed y max to 25 and y scale to 2, and now this is the graph that we're seeing. What I want you to do is take a picture of this graph on your calculator and pull it in right here. You don't have to do all the others, just bring in the graph right here. And then after you've pulled that in, I want you to put 2 red points where I have them, where x is -1 and x is 3, and draw the blue secant line. So go ahead and do that. When you do the corresponding homework, it's okay with me if you just take pictures on your calculator and pull them in like we're doing in the notes. Now we want to find the slope of that secant. So these are the points we're going to use. -1 and -7, and 3 and 21. Then we're going to find the slope by using the slope formula. So slope m equals, I did 21 minus the -7 over 3 minus -1. So that gives us 28 over 4. So that means we have a slope of 7. So that's the answer to part A. Now for part B, it says find the equation of the secant. And then after you write that in blue, grab green and write the point slope formula. Y minus y sub 1 equals m times the quantity x minus x sub 1. So we're going to substitute in for the slope 7, and I substituted in for x sub 1 negative 1 and for y sub 1 negative 7. Then I have y plus 7 equals 7 times the quantity x plus 1. Then I distribute the 7, and I get y plus 7 equals 7x plus 7. Then I subtract 7 from each side, and I get y equals 7x. So that's the equation of the secant. Then part C says to graph both, meaning the original function that we were given and the function we just found in part B. So I'm going to go to my calculator and go down to y2 and put in 7x. That will draw the secant line, because that's the equation of the secant line. So graph both in Zoom Standard, sketch the graph, and label the coordinates of all the intercepts and the points of intersection. So I'm going to graph both in Zoom Standard. There's the function, there's the secant line. And then what I want you to do is take a picture of that, pull that in underneath this. Okay? You don't have to take a picture of the equations. And then you're going to label all of these points that I've labeled here in blue. All of the intercepts and the points of intersection. And once you're finished with that, that's the end of the lesson. I hope you enjoyed it, and thank you for letting me teach you.